Hey, welcome to our channel. I'm Geetanjali, your math coach, and today we are going to learn basics of equation. This is part 1 of the series of the videos which we are going to present you for equation. In this video, we will learn what is an equation and how to solve a simple equation using basic principles and by transposition method. To begin with, what is an equation? Let's start with its formal definition. An equation is a mathematical statement that two things are equal. It consists of two expressions, one on each side of an equal sign. Let's understand this with a real life example. In real life situation, we may compare equation with the balanced state of a balanced scale, where weight on the right side should be equals to the weight on the left side to keep it balanced. Here I took a balanced scale. You can see that I haven't kept anything on either side of it and it is in a balanced state. Suppose I want to keep something on one of its side. You can see that it has lost its balanced state. Now if I want to bring it back to its balanced state, what I can do? So I need to put something on the right side as well. Well, I try with 10. It doesn't work. It didn't come to balanced state back. So what I can do to bring it back to balanced state? I need to put same weight on both sides of it. So left side I have 15, right side I have 10. So I will keep 5 more kgs on the right side so that it can come back to balanced state. You can see that same thing happens with the equation. In the equation also, left side of equal sign should be equals to the right side of the equal sign to keep it a true statement. I can express the same example with the help of equations also. Look, in this equation, on the left side of equal sign I have kept 15 as I had 15 kgs weight on the left side, and on the right side I kept 10 and 5 as I had these weights on the right side. I added them so that their sum should become equals to 15, which is equals to value on the left side. This is all about the equation. That value on the left side of equal sign should be equals to the value on the right side. Let's take a few more examples to understand, but before going deeper into it, please understand one thing, that in the equation, value on the left side should be equals to the value on the right side, but it doesn't mean that both sides should look exactly same. Those may look different also. There may be different operators, there may be different numbers, there may be different variables involved in it. It is all fine as long as the values on left side are equals to the value on the right side. In these examples, we have to figure out which are true equations. So we will stick to the basic definition, which says value on the left side should be equals to the value on the right side. So here on the left side, in the first example, we see 10 plus 2. 10 plus 2 value becomes 12, and on the right side it is 15 minus 3, which is also equals to 12. You can see that the value on the left side is equals to the value on the right side, so it is a true equation, although there are different operators and different integers involved here. Now the second example, on the left side you can see 5 times 2. 5 times 2 gives you 10. And on the right side it is 15 divided by 5. When you divide 15 by 5, you get 3. So on the left side it is 10, on the right side it is 3. It means these values are not equal. So this is not a true equation. Now let's go to the third example. Here on the left side there is a term 2 and 2. So this expression add up to 4, and the right side it is 12 divided by 3. 4 times 3 gives you 12. So 3 4s are 12. So here 4, and you see that value on the left side is equals to the value on the right side. So this is also a true equation. Now the basic principles of an equation. As you know what is an equation, it should always remain in a balanced state. Value on the left side should be equals to the value on the right side. Suppose you want to make some changes to these values. Due to any reason you want to make some changes, but at the same time you want that its true status should not go away. So you need to follow basic principles so that you get your equation remain true and you can make changes in the values. For example, here I took 10 equals to 3 plus 7. You can see 10 on the left side and 3 plus 7 equals to 10 on the right side. Suppose I want to add 5 to this 10. Now let's see what happens. If I add 5 to this 10, this becomes 15. So on the left side you have 15, but on the right side still you have 10. This equation is no more a true equation. So what I want is, I don't want it to lose its true status, so I will need to add 5 to right side as well. So we need to add same number to both sides of an equation so that it will remain in true status. Here you can see initially when started the values on the both sides were 10, but now the values on both sides are 15. It is fine. If the values changes, it's fine, but the balanced state of equation should not change, which is more important. Now let's take this example. Here we have 10 plus 5 on the left side and 3 plus 7 plus 5 on the right side. Now I don't want this 5. I want to remove this 5. Let's see what we can do to do that. I have removed this 5. You can see weight on the left side became 10, whereas on the right side it is still 15. So I need to remove 5 from right side as well so that it gets back to its balanced state. So if we subtract the same number from both sides on equation will remain true. Let's take this example. Here again I have taken 10 on the left side, 7 plus 3 on the right side. Now I want to double this value. I want double of this value. So when I want to double of this value, I need to multiply it by 2. So I have multiplied it by 2. You can see what happened. On the left side it is 20 and on the right side it is 10. So it has lost its balanced state. So I will bring it to balanced state again by multiplying 2 to right side as well. So if we multiply the same number to both sides of an equation will remain true. Now here I have 16 is equals to 10 plus 6. I don't want this 16, I want 8. So to get 8, I need to divide it by 2. So I have divided it by 2. You can see it is 8 on the left side and still 16 on the right side. And it is no more in balanced state. So I need to divide right side also by 2 to get it back to balanced state. So if we divide both sides of an equation by the same number, equation will remain true. These are the basic principles. Basic principles tell you that whatever operation you perform on one side of equation, you need to perform the same operation on the other side of equals to sign as well. Now, equation using variables. So far I have explained you everything with the help of numbers so that you understand the basic ideas. But whenever you will come across the equation, most of the time you will see some variables involved in it. What are variables? Variables are unknown numbers. Here for example, x equals to 5 plus 4. So if I write x is equals to 5 plus 4, you know what is this 5, you know this what is this 4, but you don't know what is this x, what is its value. But you know one thing for sure, if you want to make it a true equation, you should have equal value to the left side as well. So first we will see 5 plus 4 gives you 9. So on the right side you have 9, but on the left side you don't know what is the value. So you will assign some value to this variable so that it becomes a true statement. So it is quite clear that you should assign 9 to this x so that this becomes a true statement. So this now have, as if I substitute 9 for x, the equation will look like 9 equals to 5 plus 4, which is a true statement. So we can use basic principles of equation to find values of the variables involved in an equation. You understand one more thing here, that when you apply basic principles of equation, it's not necessary that you apply that only to the integer. You can apply basic principle to decimals, to fractions, to variable, anything involved in equation. It will be applied in the same manner to everything. And one more thing, to represent a variable, you can take any alphabet. For example, I took X here, Y here, B here. So you can take any alphabet, A, B, C, X, Y, Z, any alphabet to represent a variable. Variable represent an unknown quantity. If you substitute a proper value for that variable, it will give you a true statement. So to solve these equations, let's start with first equation. We have x minus 5 by 5.2 on the left side, and on the right side we have 15.3. Now I don't want this 5.2, so I don't want this 5.2. My means how I can remove this 5.2. To remove this 5.2, I need to add 5.2 to this. So x minus 5.2, if I add 5.2 to this will get cancelled, and as we know by basic principles, I cannot add 5.2 one side only. I need to add this to other side as well. You can see 5.2 I have added to both sides, and these are of different signs, so this will get cancelled. And here we get x is equals to sum of these two. Sum of these two will become 20.5. So answer for first equation is x equals to 20.5. Now let's take second example. Let me erase this. Now in the second example, we have 12 minus y is equals to 4. Now 12 minus y is equals to 4. I don't want y negative, I want y positive. So what I can do, I can apply basic principle for y. So it will become 12 minus y plus y. I have added y here, so I need to add y to other side as well. So I have added y to both sides. Now this will get cancelled, and here we have 12 is equals to 4 plus y. Now I don't want this 4 here because I want value of y only. So I will subtract 4 from both sides. So I have subtracted 4 from here and also subtract 4 from the other side. So these two will get cancelled, and you will get value of y, which is equals to 8. You can always tally your answer whether you have got correct answer or not by substituting these values at the place of the variable. For example, if I want to find out whether I have got correct value of y or not, I'll simply substitute this value in the equation. So on the left side it is 12 minus y. Instead of y I write 8. When I subtract 8 from 12, I get 4, which is equals to right side. So it became a true statement. So it is a true equation, and we have got a correct value. Now let's move to the third example. Oops. Erased now. Now 2b plus 3 is equals to 17. So we will deal with all these numbers one by one. So first we will deal with this term. So first we will subtract 3. So 2b plus 3 minus 3 is equals to 17 minus 3. So this will get cancelled, and here you get 2b is equals to 17 minus 3 will give you 14. Now to remove this 2, we divide both sides by 2. So 2b divided by 2 is equals to 14 divided by 2. So this gets cancelled. 2 sevens are 14. So b is equals to 7. You have got value of b, which will satisfy this equation. Now let's take last example. Here in this example, I have 5x divided by 4 is equals to 10. Let me rearrange these numbers. So I can write 5x upon 4 is equals to 10. So for this 4, first of all, as it's in division, we will multiply both sides by 4. So 5x divided by 4 times 4 will give you 10 times 4 on the right side. So this will get cancelled, and here you have got 5x is equals to 40. Now about this 5, let's see what we can do. So this is in multiplication. As there is no sign, there is actually hidden sign, which is multiplication between these two numbers. So now I want to remove this number, so I will divide both sides by 5. So 5x divided by 5 will give you 40 divided by 5 on the right side as well. So this 5 will get cancelled, and on the right side 5 8s are 40. So value of x is equals to 8, which will satisfy this equation. Now, as you have understood what is the use of applying basic principles, how you can find values of variables using basic principles, but you should be thorough with this concept, because this is very important concept into equation. So please pause your video for a while and practice the following problems. If you find any difficulty in solving these problems, you can contact our teachers. You can collect more sheet from the center so that you can practice more on this. Now let's move to the next part. Components of equation. Let's get deeper into the components of equation. I have taken an example here. Our equation is 2x plus 3 is equals to 7. I'll explain you all of its components one by one. This is variable x. Whenever we solve equation, we solve to get value of this variable, so that when we substitute this value here, it becomes a true equation. Variables can be, you can use any alphabet to represent a variable. Now this is coefficient of variable x. Coefficient is a number which is multiplied to variable. Here coefficient of x is 2. Operator. In mathematics, there are so many operators: plus, minus, multiplication, division, and so on. This is operator plus. And these are the constants. Now let's see once again. With the equals to sign, there's something on the left side of the equals to sign and something on the right side of equals to sign. So on the left side of the equals to sign is an expression, whereas on the right side of equals to sign is a constant. This expression consists of two terms, term 1 and term 2. Term 1 is 2x and term 2 is 3. In an expression, there can be more than two terms. All the terms are separated by operators plus or minus. Now transposition. Transposition is a shortcut way of solving an equation. Now let's see its formal definition first. Transposition means transfer of the terms of equation from one side of equal sign to the other side. But why do we do that? We do that so that we can rearrange the terms in such a way that variables on one side of the equation and rest all the terms on other side. While doing transposition, we have to be very careful that whenever we transfer terms from one side to other side, equation must always remain in balance. It should never get out of balance, otherwise it won't be true anymore and you won't get a correct answer. So where you have to be careful while doing transposition, you have to be careful about change of sign. In the transposition of the term, it is accompanied by change of sign, which is as follows. When you take one term from one side to other side, maybe from left of equals to sign to right of equals to sign, or from right of equals to sign to left of equals to sign, you have to be careful about sign. Plus sign will become minus, minus sign will become plus. Multiplication will become division and division will become multiplication. Let's see by a few examples. Let's take first example. Here we have x plus 5 equals to 7. So what I want this x to be itself here again only, and this 5 I need to take to right side so that this x remain all by itself. So what we can do, we have to take this 5 to this side, so I will write it again. X is equals to 7 and I took 5 here, I brought this 5 here. Now about this sign which is just before 5, this will become minus. So x is equals to 7 minus 5, 2. So your answer is 2. So instead of adding or subtracting or multiplying or dividing the same number both sides, we can simply transpose the terms. and you have got answer. You can always check your answer by the method which I have explained you previously. Now let's take second example. 10 minus 2a is equals to 4. Now this is minus 2a. I don't want minus 2a because I will need value of positive a. So I want to make this positive. So I will take it to right side. So when I take it to right side, it will become 10 is equals to 4 plus 2a. 4 will remain as it is, and this 2a came here, and this minus sign became plus. So now here we have 10 equals to 4 plus 2a. Now again I don't want this 4 to this side, so I'll bring it this side. So it will become 10 minus 4 is equals to 2a. So 10 minus 4 is 6. 6 is equals to 2a. I want value of a, not of 2a. So about this 2 we need to do something. This is multiplied to a. I will change its side and it will go into division then. So it will be 6 divided by 2 is equals to a. So now simplify this. 2 3s are 6. So value of a is equals to 3. We have got value of a for this equation. Now let's take next equation. Next equation is 4y plus 3 is equals to 15. Now let's take this 3 to right side. So we get 4y is equals to 15 minus 3, as this plus will become minus. So 4y is equals to 12. 12 on the right side. Now I will take this 4 to right side as well. So it will become 12 divided by 4. 4 3s are 12. So y is equals to 3. So value of y is equals to 3 will satisfy this equation. Now let's take last example. In this example we have 5x divided by 4 plus 3 is equals to 13. Now first we deal with this 3 because this is the second term. We will deal everything term by term. So we will not touch this term. This will remain as it is. We take this 3 to the right side and it will become 13 minus 3. This plus became minus. So 5x divided by 4 is equals to 10. Now this 4 I will take to right side. As it's in division, it will go with multiplication sign. So 5x is equals to 10 multiplied by 4. So 5x is equals to 40. Now this 5. This is multiplied to x. I'll take this to right side and it will go into division. So I can write x is equals to 40 divided by 5. 5 8s are 40. We have got value of this last x also. Oh, it is 8. I'm so sorry. This is 8. Value of x is 8. If you substitute 8 here, it will become a true equation. I think we have practiced sufficiently on the equation. Its basic principle, transposition, components of equation, we have done all through that. Please collect sheets so that for further practice. And let's move to the summary. In the summary, first the basic principles of equation and then transposition rule. You know, while doing transposition, you have to be careful about the sign. If you have any queries or ideas that you would like us to present, please leave the comment below. Check out also our other videos. Thank you so much for watching, and if you like it, please don't forget to subscribe.